Inst instantaneous. Oh no, that's Home Alone 3.
No, there's like 7 Home Alones.
It's true, but Home Alone 1 and 2 were both with Kevin McAllister. Those are the best ones. I gotta say, I actually read an article when I was in college that was saying that if you read between the lines, Kevin McAllister's dad is absolutely a member of the mafia.
What?
Yeah. Well, I don't know if that's true or not. Like, if the writers had that intention, it's not officially written down anywhere. But if like you look into it, like, it makes a lot of sense. Anyway, well, they've got like a bazillion dollars, and no one says anything about what he does for work. Kevin McAllister's dad, like Kevin's dad, like his dad, like he also has family members in like three of the biggest mafia cities in the U.S. and Europe. There's a thing. Anyway, use the situation below to make a table equation or graph representing it. Josh is filling the Skyline swimming pool with frogs for good cause. It's complicated. Anyway, you know how to read those if you at home. These guys have already done it. Well, you're going to want to pause the video, work on this, and let's get this show on the road. Alrighty. Here we go. Grab that. Here we go. Okay. Boop, bop, zip, zip, zap. Okay, perfect. Alrighty, so the first thing I would like to do is let's make a table for this. Would X be frogs or would X be minutes? Let's see here. Tice, what do you think? Should X be frogs or should X be minutes? X should be minutes because that's our independent variable. How many minutes has he been at it? Depends on how many frogs are in the pool. That doesn't feel as natural as how many frogs in the pool. That depends on how many minutes he's been putting them in there. Again, you can make an argument that either one could be used as a dependent variable, but for now, we're going to focus on the side that feels a little bit more right. So if I've got, what did you count your table by, Tice?
I counted my table by 1 and 1.5.
Oh, so 0, 1, 2, 3, 4, 5, 6. You know, I'm going to go all the way up to 10. 7, 8, 9, 10. And then what did you count on the other side?
1.5.
1.5. So I like it.
10 divided by 15.
Oh, that would be 0, because 0 minutes, 0 frogs. 1.5, 3, 4.5, 6, 7.5, 9, 10.5, 12, 13.5, 15. Very good. Awesome. How many of us made a table? Even if it's not just like this, we see how Tice got this table and aren't too alarmed by that. Great. You'll love to see it. Very good. Let's see here. Now, I'm going to go ahead and say, guys, that all of these points totally make sense for my math, but I would say that not all of them make sense for my equation. When I say teach, I want you to say, okay, excuse me, not equation, situation. When I say teach, I want you to say, okay, I want you to look at these points and tell me which ones, even though they make sense in terms of the math and the equation, why don't some of those points make sense for my story? Teach! Okay. Can I get you guys back up here in 5, 4, 3, 2, 1. Shh. Okay. Ada, will you please cross off the values that don't make sense in my story? Even if they make sense for the math and they make sense for my equation, they don't make sense for my story. Will you cross those ones off? Well, so for example, Ada, here's what I'm asking. At 0 minutes, there are 0 frogs. Does that make sense in my story? Was there ever a time that he was at it for 0 minutes and then there were 0 frogs in there? Great. At 1 minute, there was 1.5 frogs in the pool. Does that make sense in my story? Why not? How can you have half a frog? Again, if you cut a frog in half, either it's dead, and that doesn't count, or it's alive and it does, right? So go ahead and cross off 1 and 1.5. What other ones don't make sense, Ada? There you go. Perfect. Great. Excellent. Wonderful. Those ones don't make sense because you can't really have half a frog in a pool. And again, people will argue with me and be like, what if you cut the frog? And it's like, you guys, if somebody like loses a leg, they don't get 3/4 of a vote. They're still a full person. Do you know what I mean? So, let's see here. So I'm going to rewrite this table with just those values, and you're going to see why in a minute. 0, 2, 4, 6, 8, 10. That was 0, 3, 6, 9, 12, 15. Fantastic. Thank you, Ada. What would the equation be? What are we doing to my x's to make the y's? Melissa, what am I doing to the x's to make the y's?
Wait, what?
Yeah, what am I doing to these numbers to make these numbers? By what? Yeah, so the equation would be something like y equals 1.5x. And again, I'm not going to leave it like that. So go ahead, Melissa. You wanted to change it. Beautiful. Yep. The ideal way to write it is y equals 3 halves x. And I'm going to tell you guys, the reason I want it to look like this is very closely related to why I wanted to draw the table like this. When I say teach, I want you to say, okay, what does this 3 halves seem to be saying about my table I've got here in blue? How could I have gone straight from this equation to this table instead of the other way around? Teach! Yeah. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Taos, where do you see the 3 and the 2 showing up in my table over here?
I don't know. I'll add
That's okay. That's true. That's true. I see it one time, right? Like I see it here and here. I see it here and here. But you know what? We'll look at it. We'll look at it, okay? We'll keep looking at that because that's actually what today's lesson's all about, is the connection between the 3, 2 here and not just the 3, 2 here. Yes, that 3, 2 for sure. But more than that, every single number here could be gotten by that 3, 2. That's what we're looking for. But we'll talk about that as we go on. Let's make a graph for this. Let's see here. Miro, what did you make your graph look like? Like what did you count by? Okay, on the x-axis. So you just counted by what we had. Yeah, that's totally fine. Again, I recommend doing like, because the thing is I don't normally count by 15s. Like that's not a number I generally go to. So you might want to count by something that's a little bit more natural. Like, yeah, like tens or fives. Because if you count by tens or fives, you'll still get those 15s. I'm going to do that. I'm going to show you. And the reason that I recommend that, Mira, is because if you count by tens one way and 15 the other one, then your graph's going to be like ding, 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 ding. But then on the next problem, if we're counting like sevens and threes, if you count by threes and sevens, it's just going to look literally like the same graph. Do you know what I mean? That's okay. So I'm going to count this one by tens, you said. 1, 2, 3, 4. Let's do this. 10, 20, 30, 40. I'm going to make the little 5 in the middle. And then I'm going to make the little ticks as well. 1, 2, 3, 4. 2, 3, 4. Okay. And then I'll count by 5s. That feels a little bit more natural. 1, 2. We'll do same thing here. 5, 10, 15, 20, 25, 30, 35, 40. And you know what? I think I do want 45. So I'm going to pop it in there. 45. Then I need the little ticks, right? 1, 2, 3, 4. 1, 2, 3. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I know, I get into a weird rhythm when I'm doing these things. But anyway, if I'm going to graph the points on I'm going to do this table here on the left because I don't know about you. I understand where 1 comma 1.5 is, but I don't want to graph it. How many of us feel that exact same way? I know where 1 comma 1.5 is. I don't want to put it down there, though. I'm right there with you. So we're going to do 0, 0. I need a good froggy color, though. How about this one? That's a good froggy color. And then 2 comma 3, 2 comma 1, 2, 3, 4 comma 6, 6, 6 and 9, 8 and 12, and then 10 and 15. And then Mira, I'll bet you got even more on here, right? Because you were counting by tens, at tens and 15s. What other points did you get on here that I didn't get on mine? 40, 60? Oh, I can't fit that one on mine, unfortunately. How about 30? Oh, did you get 30? If you were counting by tens, that's okay. Oh, I see, I see. So, well, if you look at your table, because I'm assuming you counted your table 0, 10, 20, 30, 40, 50. Yeah?
Yeah.
And what was on the other side of those?
Oh, 50, 45, 60, 75.
I gotcha. So
That's all
15.
I went up to.
Yeah, so that would be 15, and then 20 would be 30.
Sorry.
No, you're okay. 30, 45, and then I actually run out of room. But you guys will notice that I can connect those with a line. It would be a dashed line because it is, we're counting frogs. But again, no one's going to test you on whether it's going to be dashed or solid. But here's the big idea. This is what we're chasing today. Today, guys, this 3 over 2 isn't just telling me this 2 through comma 3. It's actually telling me 4, 6, 6, 9, 8, 12, 10, 15. I could keep going. 12, 18, what would that be? 14, 21. How many of us think we see how the 3 over 2 is informing every single number in my table? Cool. And then we're going to turn that into a way to make this graph. Because it turns out, guys, that 3 over 2 is actually informing every point on my graph. How many of us think we see that relationship? Really? More on that one than on the table. That's curious. I love it, though. Let's do it. Let's see here, guys. It is the 71st day of school. You know, since 7 factorial plus 1 equals 71 squared, 71's a Brown number.
What?
So a Brown number is a number. I don't think 32 is a Brown number, but if it was, 3 factorial plus 2 would be equal to 32 squared. And I know for sure that that's not a Brown number, actually. I can see it. A Brown number is a number where, like, you take the first digit and make a factorial and add the second digit, and you should get that number squared. You probably are confused because you have no idea what a factorial is. It's because it's named after the guy who discovered them, Brown, Dr. Brown. A factorial, I'll help you out with that. Maybe you can catch the pattern. 1 factorial is 1. 2 factorial is 2. 3 factorial is 6. 4 factorial is 24. 5 factorial is, ooh, that was incredibly close. 120. 120. 6 factorial, let's see here. Yes. Is it 720? Yeah, I think it is 720. Mm-hmm. Henry got it. Oh, it's on your calculator. Do you know why it's 720?
Because it's 7 times 6 times 5.
Yeah, it's 6. That's perfect. Guys, a factorial is kind of a weird thing where it's 6 factorial is 6 times 5 times 3, 4, excuse me. 6 times 5 times 4 times 3 times 2 times 1. And it turns out that those are really important numbers in statistics, and you'll learn a little bit about why later. Yes, Liam.
Or you could just do 6 times 100.
Yeah, you can also do that. 6 times 5 factorial. It would be also 6 factorial, because you can just take your previous number and multiply by the next one. So if I wanted 7 factorial, it's just 7 times 720. But in any case, guys, it's Rockefeller Tree Lighting Day. You guys know in New York, the Rockefeller Plaza, where they have that enormous Christmas tree? They always light it. This is so weird. They always light it 6 days after the 4th Thursday in November.
That seems
Every year. I know, isn't that weird? 6 days after the fourth Thursday
6 days
of
after
November.
Thanksgiving.
Well, it may or may not be Thanksgiving, because Thanksgiving is the fourth. It's the fourth Thursday, unless the first is a Thursday, in which case it's the third. No, third. No, it's the. I think it's the third Thursday actually, unless the first is a Thursday, in which case it's the fourth. I know it's weird. It's almost as weird as Easter, but not quite. Easter is the weirdest holiday. Like where it goes on the calendar is bananas.
Like,
We'll talk about it when we get there. Let's see here, guys. Let's do it. Addie, what's our first essential question today? Yes, I'm so sorry, Addie D. I forgot. I need to specify. How can we use the constant of proportionality to graph proportions directly? Okay. Our Jeopardy this week is national birds. This large flightless bird and cousin to the ostrich is the national bird of Australia. Ask Doug if you're not sure. I got inspired by the person who said limu emu. Yeah, because it is an emu, is correct. And then snowblank, snowman. You know what? I think the way Pictionary works, I think I have to take maniac because it's got man in it. Someone said maniac. I'd be like, yep, you got it. It was man. All right. What's that? I don't know. It's an interesting bird, isn't it? All right. Come on up in 5, 4, 3, 2, 1. Underneath all this, got a pencil? Today we're graphing proportions directly. Okay, let's start simple. Y equals 2x. This is what we call, this is just a proportion that's just sitting out there in space. Y is 2 times x. Y is 2 times x. And if I make a table, x and y, and I put these numbers on my x's, -3, -2, -1, 0, 1, 2, 3. It's since this is just numbers floating around in space, there is no context and negative numbers are totally allowed. It's just saying, all I'm saying is y is 2 times x. If you want to know what y is, well, you just take x and multiply it by 2. When I say teach, I want you to say, okay, how could you fill in the rest of this table if y equals 2x? Y is 2 times x, whatever x is. Here's your x's. What are your y's that go to go with them? Give it a shot, and here we go. Teach! That's fine. Do you have a phone on you? Wonderful. There you go. No, it's nada. Alrighty. Can I get you guys back up here in 5, 4, 3, 2, 1. Crew, if that was an excellent countdown from 5. You guys are absolutely crushing it today. Thank you so much, everyone. I love it. You guys are working with your partners. You're coming back from those countdowns. You guys are doing awesome today. Crew, if y is just 2 times whatever x is, if x is -3, what would y be? Yeah, because that's just 2 times -6. What if x is -2? What's y? And if it's -1? Keep it going. Uh-huh. Beautiful. How many of us were able to get those or see how crew got those and aren't too alarmed? Beautiful. Let's get this on a graph. Now, in the interest of time, guys, because these graphs can be annoying to make, I'm going to have you make one that's kind of large, but I'm going to try and make it the only one that we make today. Make a graph that goes 10 every direction, please. That's 10 up, 10 left, 10 right, 10 down in all four quadrants.
Oh, yay.
Mm-hmm. Perfect. While you guys are making that coordinate plane, I'm going to hand around a couple of items for you. Let's see here. Can I get away with this one in this class? One, two, three, four, five, six, seven. 1, 4, 5. Yay! Okay. Ah! Oh yeah, and if you haven't already, guys, if you'll make 2 little stacks at your table with your finished self-assessment in one stack and your situation sheet in a different stack, I'll come and gather those shortly. Okay. Right. Okay, I've just given you guys a bunch of. Oh, sorry, you're still working. My apologies. Give you guys another 20 seconds to finish that off. What happened to my calculator thing over here? Oh, just came a little loose. Whoop. And then, Andy, we're just making a coordinate plane that goes 10 each direction because we're going to graph that on there. All right. And then if you guys are wondering why I just gave you some colored pencils, it's because you might notice that I color code these lines. And I do that to make it so that it's easy to refer back to my notes and I can say, oh yeah, that's my red line. Oh look, there's my orange line, right? So, and even if you already did this in black, you can go ahead and underline it in red. And then we can go ahead and draw this in whatever color. And you don't have to use red. You can use whichever the heck color you want to. So this has -3, comma -6. 1, 2, 3, 4, 5, 6. -2, comma 1, 2, 3, 4. -1, comma -2. 0, comma 0. 1, comma 2. 2, comma 4. 3, comma 6. And then we're going to connect those with a solid line. When there's no context, when there's not a story to go with it, we're just talking about the numbers, and all of the numbers will always make sense. You can always say, well, if y is 2 times x, if x is 3.87874, then you could do 2 times 3.87874, and whatever the heck that is. It's going to be on my line somewhere. It's going to be on this line somewhere, just like that. How many of us by raised hand either got that line or we see where that line came from and we're not too alarmed? You guys going okay with that? Cool. Go ahead and finish up graphing it. Go ahead and finish up graphing it. Okay. Adjust that a little bit. There we go. Perfect. Let's do another one, guys. Got a pencil? Well, we can do better than that. Got a pencil? Y equals 1/2 x. I would do it I'm going to do it in a different color because that way, when we go from here to there, I can see my red line's the red one, the blue one's blue. You can also just number them. Like, if you want to, guys, you can say that's number 1. And then this one over here is going to be number 2. That works too. Let's do it again for -3, -2, -1, 0, 1, 2, 3. If y equals 1/2 x, how would I get my y's if x was -3, -2, 1, 0, 1, 2, and 3? Give it a shot, and here we go. Teach! Yeah. And then, yeah, graph that too if you want to. Graph that too if you want to. Any self-assessments here? Got a couple here. Love that. Love that for me. There we go. Oh. Any self-assessments? Just one. Yeah, I'll be collecting this all week, guys, so don't worry. It's not technically due until Friday. Okay. All right. Can I get you back up here in 5, 4, 3, 2, 1? Let's see here, guys. So how would you fill this in for all of these here? Luke, how would you fill in the y's for this side? Mm-hmm. I don't want to graph those decimals, do you? We could. You could graph the decimals, but I really don't feel like it. So I'm going to put down 0, 0. Looks like -2, -1, 2, and 1. That doesn't seem like very many points. I would like more points on here. Maybe I should count by something else. Let's make another table really quick. Can someone by raise a hand tell me, what do you think we could count by instead of by ones to try to avoid all these nasty little decimals coming up? You have an idea, Tice, or just stretching?
No, I have an idea.
What's your idea?
It's 2. Count by 2.
What if we just count by even numbers? What if we do -4, -2, 0, 2, 4, 6? I already know 0, 0. I already know -2, -1. I already know 2 and 1. What would those other 3 be, and where would those show up on my graph? Give it a shot and teach! Okay. Can I get you guys in 5, 4, 3, 2, 1? Let's see here. Tommy, what do you think should go in with a -4? Or let's see. So remember, that would go with the first one. This next one is 1/2 times x. So what's 1/2 times 4? Oh, sorry, 1/2 times -4. -2. And then a half times 4? 2. And what half times 6? Very good. So we have a few more points we could put down there. -1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 6, and there we go. Okay, how many of us were able to get a line that looked something like this. A line that looked something like this. Okay, now here's the big question. This is really the big idea that I'm trying to get at. I'm going to tell you right now, this fraction told us what to count by. How did that fraction tell us to actually, this fraction was trying to tell us to make this table that I've got highlighted in pink instead of this table from here. There's something that this fraction is doing that's telling me to use this table over here instead of this one over here. When I say teach, I want you to say, okay, how is this fraction telling me to write this table? Teach! That's okay. Can I get you in 5, 4, 3, 2, 1? Skylar, how is this telling me to do this? That's true. How did this, though, because the thing is I could have made this table using that, right? That's what we did initially with Luke. But I'm saying that this fraction is somehow telling me to make this much nicer table to graph. Do you see how it's doing that? That's okay. That's okay, Skylar. You don't have to know that. I appreciate that you're looking at it, though. Annie thinks she's got an idea, though. Yeah, the 1 over 2 is trying to tell me to do this table instead of this one. How?
Because like one, I don't know how to explain it. Like 1, 2.
Will you point again, though? Hold on. I think actually, just say it again with the pointing.
Like 1, 2.
Yeah. Okay. So I'm actually going to give you this. What's your favorite color?
Purple.
Purple. Will you go ahead and point arrows and say 1, 2 again? Hang on.
Arrows.
Yeah. So like point. You don't have to put it in here. Just point like point to like do the pointing on the screen so everyone can see it now.
1, 2.
Yeah. There you go. Perfect. So what Annie is noticing here is that on my Y side, I'm counting by ones. On my X side, what am I counting by? Twos. Over here, what was I counting my Y side by? What was I counting my X side by? Twos. That fraction is trying to tell me to count by the correct values. Now, there's more that we need to talk about, but you guys are super winning the scoreboard game in the last 5 minutes, so we're just going to let it rest at that. There is no self-assessment, guys. Since you guys are in the lead, once I get all my rulers, and in fact, the first person at your table how about this? The person who's going to give me my rulers after checking them for vandalism is the last person at your table who can count to 12. Oh yeah, I'm fine. Okay, if that was a tie, 20. Okay, and then guys, you're welcome to move around, pack up those colored pencils and put them in the center of your tables. My next period is going to need them also.